Welcome to this episode on data visualization, part of a series of short films supporting courses I teach in data science and artificial intelligence. You can find more by following me on LinkedIn or as @Binocularity on Twitter. Thank you for watching. So this episode is about data narrative. How do you create a story, a narrative about data that gets across the main points in the data that you want to convey to people? And we'll see an example of how to do that. Going back to narrative, it is about telling a story. The ancient Greeks knew about this, and Aristotle introduced some of the basic structure in Poetics in the 4th century BC. And a lot of stories have a 3-act part to them. Act 1, you set the scene, there's an exposition. And in part 2, there's some kind of conflict or a question that builds suspense. In Act 3, there's a resolution, some kind of ending that brings together the threads of the story. There's a problem with this, that it's not really about data. It's often about people, but we'll see how we can fix that. Here's a short haiku poem from Matsuo Basho. He wrote these poems in a short number of sentences and a short number of syllables, very defined formal format. And this one is, "In the cicada's cry, no sign can foretell how soon it must die." Now, there's a number of features in this. You set the scene, there's something happening with the cicada. You can't tell something. There's a question, there's some suspense. What is it that you can't foretell? And then a resolution, the ending with a punchline, how soon it must die. And that kind of structure works very well in many stories. It's often conflict is the heart of this. In data, we need to move that conflict into questions. So you need to set the scene, create the questions, and then provide some answers to those questions for people. There's a number of areas of work where you can draw from in helping to produce narrative structures. Documentary storytelling is one of them. And there you can let the data tell the story. Very often in documentaries, they wrap the story around a person and their life and their experiences. Very often we can't do that because data is raw data. There's no people involved. Sometimes you can, and sometimes it's helpful. But we present these abstract entities and we can still use these same rules of storytelling. Cole Knaflic has a great book on storytelling with data. How do you construct a 3-act data story? You set the context, the main data characters. You bring out the questions that will be answered. You describe the data and the difficult questions. And then you come to the conclusions. And she always recommends some kind of call to action at the end. What is it that you should do next now you understand this data? In statistics and data science, we would normally say we're trying to inform people. We're trying to give them an idea of the data, the certainties and uncertainties in the data. And we're not trying to persuade them to take a course of action. We're leaving the action part and the decision part to the receiver of the information. But that's not always true. She's got a great video that you can watch on YouTube. Another way to think of things is legal argumentation. And the way in which lawyers present arguments is sometimes quite different to the way we might think of it in a story or a normal narrative. The first thing they do is present the conclusion. So it's quite a good thing to do in all rhetoric and say, I think the conclusion is this, and then go on to say the evidence and the reasons and the rules. So in law, you can state from case law, the general rules that you'll use. You can bring in evidence and apply case law to the facts, and then summarize the facts and come to a conclusion which you believe the court should act on. And one of the interesting things here is this red team, blue team style of legal argumentation, where you argue both sides of the argument. You take a burden of proof from the facts and a burden of rejoinder from the fallacies, and you say, if this is going to be true, then these are the facts and these are the arguments. And you're going to say, if this is going to be false, these are the facts and these are the arguments. And that contrasting set of arguments can be quite powerful. Okay, so what I'm going to show you next is a construction of a story using PowerBI around data from the Jon Snow cholera data sets. And it's a story about deaths and a data visualization from that. So in narrative and storytelling, we're looking at producing Power BI visualizations that convey a message that's slightly more than or in addition to the data. So we're going to look at one. This one's structured around a person's life and work, but it's really the data that's the key thing here that has the messages in it. We're going to work with this Power BI file and start from a blank file, but with some data in it. So if we look at the fields available in the data, I've read in 3 spreadsheets, one dates, one pumps, and one deaths. And this is a data set that relates to an outbreak of cholera in London in 1854 and has been reconstructed backwards from contemporary records and more recent research. So the person who worked on this data was Jon Snow. He was born in York on North Street and baptised here in All Saints Church, just over the road from where there's a memorial now to him by the river. He has a garden and a replica pump and pump handle. We'll come back to the pump and the pump handle later because it's an interesting story. What's of interest to us, perhaps more than the fact that he was in York, is that his early career was in Newcastle. He was sponsored by the Stephensons, who were the railway engineers and the steam engine engineers, and he came up to Newcastle and worked with William Hardcastle on Westgate Street, which was here down from not very far away from where the current USB and the computer science buildings are. He will certainly have witnessed cholera epidemics in York when he was growing up, and there was a large epidemic in Gateshead in 1831 to 32, so he'll have seen that as well. By the time the London outbreak was happening in 1854, it was something he'd known about mapping because the Gateshead outbreak was very well mapped locally. He hypothesized that cholera was a waterborne disease. At the time, there was some debate about this, whether it was waterborne or was airborne. And he collected data to try and understand this and georeferenced it back to a specific house and street so that he had a good indication of location of the deaths from the disease. We're going to plot first scatter plot. So we're going to create a scatter plot and we're going to create one of the area of the deaths from this disease on an XY axis. We've got X and Y and victim ID to details. And you'll see straight away that the cases are distributed in a certain way that's hinting that there's a regular grid pattern here because of the main streets through Soho. I'll just adjust the axes here so that you can see them a bit more clearly. 6 to 20 on the x-axis and between 4 and 20 on the y-axis. So now just that adjustment puts it in the center of the plot, the data he collected. He didn't collect it necessarily alone. People went out and helped him, but he recorded certainly the data across all of the areas of around Soho where this outbreak was happening. I'm just going to copy this and paste it onto the next slide. So in this data set we used where the deaths are. Now, if your hypothesis is where the water is, then you want to know where the water pumps are located that people are getting their water from. So we'll start to plot that. So here's the pump locations, and I highlight them as being different. We'll just change the data color to black. So we'll use label to distinguish them, and then when we switch on category here, you can see that it puts the names of the streets that each pump are on the plot. And you can see that this plot is on the same scale as this plot, so this is the area. And you can kind of see immediately that there's a particular water pump in the middle here, which is kind of in the middle of this plot of the deaths. So just looking at the raw plots, you might begin to suspect that if it's a waterborne disease and it's coming from a water pump, then it might be this one that's the issue. One way we can identify if the water pump is the issue or not is to add in average lines. That one is a vertical average in X, so we'll make that a dark color. Okay, so we've added 2 average lines now, one horizontally and one vertically, and I've put onto them the average coordinate position horizontally and vertically. And you'll see it's pretty much in the middle and not very far off where this Broad Street pump is. So the Broad Street pump is at 12.7 and 11.73, and the vertical position is 11.7 and the horizontal position is 13. It's pretty much exactly the closest pump to the center of the outbreak. So just looking at descriptive statistics, plotting this data as Cheeky would recommend, you can immediately see the 2 plots starting to tell a story about data. So it doesn't imply causation, but there may be a link between the pump location and the fact that the center of the outbreak is almost exactly on top of the pump. And given that the time people would walk to get water, it's got to be in walking distance of that pump. The next thing I want to show you is the time course of this outbreak. So we're going to use a bar chart for this. If you both plot by date, sort by date, add the attacks, which is the day on which cholera was infecting people, and then deaths, which is the time at which people were dying, you'll see a number of features come out, one of which is the speed at which cholera attacks and kills people. Almost a day or two after you're first diagnosed with cholera, if you're seriously ill, you're going to die. You'll see another thing is that things picked up and then dropped off more slowly. So there's a very rapid outbreak, and then suddenly it dropped off. Snow removed the pump handle on the 8th, and so we're going to add in a small shape to show that. Let's go for a line, and we'll put it over the 8th here. This is the day on which Snow removed the pump handle. And you'll see that that was significantly after the main part of the outbreak, and also the majority of deaths had happened. So it wasn't, he knew at the time, and actually wrote at the time, that although he had removed the pump handle, or had the pump handle removed, then by the time it was removed, deaths had already started to decline. The number of fatal attacks was much diminished. And he says here it's not improbable the water had from some other cause ceased to contain cholera. And it indeed was true. There's a later investigation, and we'll talk about that in a minute, about what happened later and why the pump handle removal was perhaps late. Now, let's see if we can do a cluster analysis on the data. So I've dropped in a cluster tool. You can find those online, and it's here. So it's one of the options you can download from Get More Visuals. And the clustering tools has let me plot X and Y, just the data points, and then work out a set of clusters in those data points. In this case, it's clustered it into 5 clusters, and the k-means approach for clustering them results in these 5 clusters where points are closer to the mean of that cluster than any other cluster. The important thing here is this region here, which is empty. And you can see through this cluster analysis that a part of the area where water is drunk from this well hasn't been affected. And if you read the text, you will see that that area was a brewery, and that the proprietor of the brewery reckoned that they never drank anything from the well. So if they wanted water, they didn't need to go to the Broad Street pump. So there you go. A cluster analysis may have been helpful in identifying some evidence that this disease was waterborne. So I'll conclude talking about sources and the source of the outbreak. This was quite a major public health emergency at the time, and cholera was a key factor in that. And there was an inquiry. Henry Whitehead, who helped with Jon Snow's original investigation, he concluded that there was a drain near the well that was the most likely source. So there was a house above there. They knew that there were people and children in the house who were infected by cholera, and they reckoned that the drain from the house was flooding into the well, and the water from the drain was affecting the water in the well. This didn't prove causation, and causation is an incredibly difficult link to make. Later on, studies did show that cholera was waterborne, and Robert Koch did this in 1884, and earlier, just slightly after this outbreak, Filippo Puccini in 1854 both showed that the bacteria Vibrio cholera was waterborne and could be ingested and would then infect you. Right up to date, it was only 3 years ago in 2017 that the WHO committed to a 90% reduction across the world in the cases of what is an almost entirely preventable disease by 2030. If you want the data from this, it's in the R Historical Data Archive. Okay, well, thank you again for watching, and we'll be back soon with more about data science and visualization.